This video is hopefully the first in a series where I will be looking at constructing a combat robot using hardware from Poundland. Poundland is a shop, you probably know, you can get things for pounds, nice and cheap, it's pretty low quality, so there's a kind of attraction there for me. So I'm just going to talk through the design of the robot that I'm going to be trying to make and how it will be made, basically. So looking at robots, I myself like the Spinner in particular, which if you've seen combat robots programs such as Robot Wars, and I think the American version is BattleBots, there's a big spinning disc or flat bar with some kind of motive on it, like that. It spins, has lots of rotational kinetic energy, and when these contact the enemy robot, it does a lot of damage. So I want to incorporate that along with a kind of low ground clearance and a kind of wedge shape, so it would be that plus a wedge of some kind. So the look I'd like to go for is something like this. With some kind of wheel in under there, and that would be the kind of deadly blade, which would rotate at high RPM, seen to the side. So you've got your wedge here, flat panel of some kind for maintenance and that kind of thing, angled back, not too sure about that at the moment, and low ground clearance at the front, nice flat bottom with very low ground clearance, wheels maybe smaller, they come in like that, and very large sort of, try and make that circular, very large spinning heavy blade at the front. The theory behind this is if you've got the ground here, your enemy robots will ride up on the front of the robot, lifting their underside off the ground and allowing the spinning blade here to impact under the kind of lip of the enemy robot and tear it up, hopefully causing some kind of damage. So the things that will be required to operate this, as it will have two-wheel steering, so that's 2 times steering motors, one motor to drive the main wheel, this is getting messy already, and some kind of control system and power management system. So let's have a look at what I've got planned for that. So far for control, it'll just be regular radio control receiver and a 2.4 gigahertz transmitter. Coupled to what I'm thinking at the moment is what's called a DigiSpark. This is essentially an Arduino, but very small form factor and less output pins. It operates on a ATtiny85 chip, which has, it's an 8-pin chip, but I think it's got 6 in-out pins, and I'm not too sure if they're all pulse width modulated or not, but it's useful for small projects and projects like this where things might get damaged and you perhaps don't want to sacrifice an entire Arduino. So the receiver, ideally, will communicate with this. I'm not too sure, I need to work out the code and if that's possible for sort of allowing the radio controlled pulse width modulation to communicate with the Arduino. And that will also communicate with a regular brushed speed control, which will then control the speed of DC motor that was just measuring the stall speed of this so that I could make sure that it wasn't going to draw too much current. But this is a motor from a printer. Printers are really useful for finding all sorts of spare bits. You can get them for free on various websites like FreeCycle. Other websites are available. And this will be coupled, it's a 12 volt motor, it will be coupled with a synchronous belt, which is also from the same printer, tensioned hopefully by something like this, which is again printer parts, and that will drive the front spinner at sort of a high speed, and hopefully it's got enough torque to get it up to speed quite quickly into the hypothetical combat robot battle. So that's the speed control. Digispark. Okay, so to control the steering, I'm planning on using two of these. This is a 12 volt gear motor operating at quoted. It was quoted by where I bought it at operating at 300 RPM. I looked at various RPMs and I decided that 300 looked about right for sort of robot wheel speed. It wasn't going to go really overly fast or not fast enough to gain any kind of advantage in the fight. So these were just bought from eBay. Unfortunately, most of the stuff here isn't from Poundland because Poundland has a sad lack of, proper electronics components. So, however, these will run and drive these wheels, which are fitting on like that. These are, what are they now? They're caster cups from Poundland. They take your wheel casters to not damage your carpet. So that'll go in there like that. There's a wee flat bit on the shaft that I've cut a flat-sided hole. These, I'm not quite sure how they'll get fixed on because they've got that kind of waxy feel. They feel like polypropylene or something, and polypropylene tends not to take glue or any kind of solvents particularly well. So I might rough up the inside there with some sandpaper and just fill this whole cavity with epoxy just to hold them in place. And also this will need some kind of grip. I'm thinking just hot glue or some similar kind of grippy substance. So that's the two of those for the wheels. Two of these 12 volt motors for the drive. And to drive them, because you can't pull that kind of current through the chip on the Digispark or else it will fry it in short order, a L298N motor driver. This drives either one stepper or two DC motors like we have here through these tunnels here, but one of the nicer things about this is it has in it what I think in the radio controlled community would be called a battery eliminator circuit, whereby the input voltage of 12 volts is stepped down inside this handy chip, or driver I guess, to 5 volts as well. So that enables the Digispark Arduino to be driven from this without any lower voltage converters because it's all contained in this board, which is very handy for a combat robot where you're going to be using multiple voltages like that in a situation where it's going to be getting bashed about and you don't want extra components causing extra failure points. So that'll take power in from the battery. Which pin was it? It was that one. So power in from the battery, and it will give 5 volts out to the Digispark, and then it'll drive both these motors nice and neat and steer the robot. The power supply I intend to use is lithium polymer battery, 11.7 volts, 3 cell LiPo. This one was second hand, so someone has removed the label for me, which was nice, so I had to go and look it up. But that is as close to 12 volts as makes no difference, so that will be quite a useful thing to drive the motors at their rated voltage. So that can go there. So that's how the control will work. As for the chassis, I'm planning to use some oven trays from Poundland, because they're the kind of most sheet metal thing you can get from there. So something a bit like this. Cookie pan, nice and armoured. And let me just get these out of the way. That will hopefully hold all the components in place for the battle. I think the best way to mount them would be to have, I'll actually draw it at full scale, that might make it easier. Have the two drive motors like this, if they're going to stay. Have the control circuit behind them. This is the front, by the way. Have this weapon powering motor here with the synchronous belt like that to drive the main spinner weapon, which would go here. Due to the scale of this, it won't be doing the same kind of damage as the big ones that you see on the TV, but enough damage is always fun. The Digispark would possibly go somewhere here, maybe getting stuck onto the heatsink of that. That might not work in my favour, however. The wheels would go here and here, allowing differential. Is it differential steering? Yeah, differential steering, like a tank. So the hole in the underside plate there for the wheels to go through, and the underside plate would look something like this. Sort of coffin shape. This is the first time I've drawn this out, so I'm making this up as I go, so forgive any mistakes. So to make that out of a single sheet of metal is not possible, but planning on using two oven trays and then folding them and cutting them, or cutting them and folding them in that order, and using pop rivets to stitch them up along the edges to make this shape. So the top, looking at that, the top piece would probably be a pattern something like this. With tabs here, and here, and here, and here, and here, and here, and of course around all the edges. These would all be drilled and folded. Get the idea. And that would meet up and pop rivet onto the base, the coffin-shaped piece. So that edge there would go to that edge there, that edge there would go to that edge there, and the whole thing would fold down and then make a nice kind of, that would obviously need the slot for the weapon, and maybe a slot there. Make a nice kind of robot shape. Ideally. Something like that. Problems I can see using the oven trays from Poundland are how to mount things. Because of the tray, they're so wobbly, they'll require maybe a wee bit of stiffening in places, so that might mean riveting on additional L-shaped flanges, like so, just to give it a bit more stability in a second dimension in another plane, to stop, say if you've got a plate like this, to stop it from going like this. You could put one of those on it, rivet it along, and that would help strengthen it in that dimension. So to attach the motors themselves, they've got these M3 holes. Oops, hold that in the middle. M3 holes that accept bolts to bolt them onto a plate. So I would imagine to make some kind of, let me just think about this, some kind of plate that's shaped like this. With two holes here for the bolts, and then pot rivets again. Pot rivets I'm choosing for this because they're nice and cheap, and you know they hold fairly well. And that would fold along these lines and those lines to make a nice motor bracket, I guess you'd call it. There would also need to be a hole in the middle there for the shaft to come out of. Then the motor would just sit in there, like so, and be pot riveted on along these lines. One of the troubles I can see with that is that because the motor is held at this end only, it might want to shimmy up and down a bit like that. But I'm hopeful that there's not going to be so much downward pressure on the wheels that it's going to do that, and also the pressure coming, or the forces coming from the wheels, will be acting upwards on this short shaft here, and so there won't be as many forces at this end of the motor where the wires are and everything. So that's the thought behind that. Similarly for mounting the other motor, the weapon powering motor, it's got these screws. Yeah, so that's the plan for that. The main weapon itself has yet to be decided on the construction. However, being driven from a synchronous belt, well, I say synchronous belt, what I'd prefer personally is to have the drive motor with the synchronous belt gear, or driving gear, and then the belt comes off it, goes through a tensioner to keep the tension of the belt, but then goes on to another wheel that does not have teeth. So seen from the side, tensioning wheel, weapon wheel, drive wheel with the teeth, synchronous belt. The reason for that is not having it meshing with the weapon means that it's not directly connected, it's only connected through friction, which would mean that should the weapon get jammed at any point, we won't end up drawing the full 1.2 amp stall current out of this motor. It will continue to spin and it won't be stalled, basically, so that eases up some of the power requirements. It might not spin up as fast as it would have done with a direct drive. However, I think in this case that will probably work alright. The weapon itself, I'm considering using a metal lid of some kind of mason jar. I've seen them in the shop, they're sort of so big. And then having it like that. Then drilling a hole and inputting some kind of threaded rod into it. Thinking M8 at the moment, see seems to be a fairly decent size. Having that come at both ends. And then basically pouring concrete or cement into this cavity. Or, yeah, to increase the weight and therefore the rotational kinetic energy of the weapon when it's at full speed. To give it an actual bite on the enemy robots, before the concrete's cast, some bolts can go through this into the edge. So if that's the edge of the weapon, say the bolt can go in like this, just through the side, and then that'll act as a wee nub on the weapon that can then catch the enemy and sort of tear bits off them in a kind of spectacular way. The bolt could also be sharpened, so you take a regular, maybe a hex head socket nut, or a hex head, yeah, socket bolt rather, and then grind there and there like that to make a nice sharpened bolt that you can then put in at the right angle, and then it'll act like a kind of a pickaxe or some kind of axe tip to grab and tear bits of enemy robot in a kind of good fun way. So when that's cast in concrete, it'll be nice and heavy, and I'm thinking that the synchronous belt can just go directly onto the shaft. I'm not sure if that's a good idea. The shaft might need some kind of collar around it or epoxy to fill in the threadings. That'll need to be worked out in the testing when it comes to that. But yeah, that's what's going on for now, and hopefully in future videos there might be some more working on it and making things function.